Lesson 3.1 covers a review of linear equations. In this lesson, we're going to look at linear equations. And first, we want to consider that a linear equation has two main forms. The first form we're going to look at is the standard form or the general form. This form is ax plus by equals c. In the standard form, a and b are coefficients. They're numbers that come in front of variables. And c is a constant, and that's a number by itself. Well, the x and the y are the variables, and these form all the solutions for the equation. Some special notes on the standard form, the ax plus by equals c. First, the variable terms are on one side and the constant term is on the opposite side. Some books do put the c on the side with a and b, and they set this equation equal to 0. But for this class, we're going to put the constant on the other side, the opposite side of the variables. Next, the entire equation should contain no fractions. So in standard form, the a, b, and the c are going to be integers. They're not going to be fractions. And finally, the coefficient of x, which is your a, cannot be negative. So if you're asked to put an equation in standard form, make sure that the x and the y terms come first and that the constant is on the other side of the equal sign. Make sure that there are no fractions and that your leading coefficient, that x, the coefficient for x, is positive. The other form of a linear equation is slope-intercept form, and that's y equals mx plus b. In this form, your m is a coefficient and your b is a constant. M comes in front of the variable x, and your b is a constant. It does not have a variable with it. And like the general form, in this slope-intercept form, x and y are the variables, and they form the solutions for the equation. Now, some special notes about slope-intercept form. Y is isolated. That means y is completely by itself. Its coefficient, the number in front of it, is an understood 1. The x term and the constant are going to be on the other side of the equal sign. The term with the x comes before the constant. So when we get into the next section and you're coming up with equations, always put the x term first. And then finally, m and b have a special meaning. You might remember from a previous algebra class, m is the slope and b is the y-intercept. In this equation, we're not going to focus on the slope and the y-intercept. We're going to graph using other methods because they're more convenient in later lessons. So now let's consider the equation x plus y equals 5. And I want to know what are some solutions to this equation. And if you remember, x and y form the solutions. So I'm basically asking what are two numbers that I can add to get a 5. So one example would be 1 and 4. And this is just an ordered pair where x is 1 and y is 4. If I add those, I get a 5. So 1, 4 would be a solution to this equation. I can also reverse those. This is a completely different solution because my x and my y values have changed. Another solution would be 2, 3. X could be 2 and y could be 3. And I can also reverse these and get 3, 2. Then I can also use negative numbers. X could be negative 1 and y could be 6. And if I reverse those, I get 6, negative 1. I can also use decimals. X could be 1.5 and y could be 3.5. These add to give me a 5. And then I could also reverse those. So then we ask, especially with the negatives and the possibility of using fractions and decimals, is it possible to list all of the solutions? And the answer would be no. I could keep using the negative values and the fractions and decimals forever and never list all of the possible answers. So what I want to look at is I can represent all the solutions through the use of a graph. I'm not able to list all of the ordered pairs, but I can draw a picture of them. A linear equation will always graph as a line. The solution to a linear equation is every point on that line. Put a star by this in your notes because this is really important. We're going to come back to this in a future lesson. So the solution to a linear equation is every single point on that line. In order to graph a linear equation, you have to have at least 2 points or at least 2 ordered pairs. Well, let's look at completing tables of values. Suppose I have the equation x plus 2y equals 10, and I want to complete the following table. In the first line of my table, the x is a 2, and I want to find the y value. I find the y value by plugging a 2 into the x in the equation and solving for y. When I get that value, I'm going to write these as an ordered pair. So in this class, you're always going to enter the final answers as ordered pairs. So let's look at when x is 2, I start with the equation x plus 2y equals 10 and replace the x with a 2. So I'm going to have 2 plus 2y equals 10. Now subtract 2 from each side and you get 2y equals 8. Now divide each side by 2 and y equals 4. So the y value is a 4, and this gives me the ordered pair 2, 4. So never stop at the table. You're always going to give the final answers as ordered pairs. Next, x is 0. So start with the equation x plus 2y equals 10, and we're going to replace the x with a 0. Well, 0 plus 2y is just 2y, so I end up with 2y equals 10. And if I divide each side by 2, I get y is 5. So if you want to put the 5 in your table, you can. But this gives me the ordered pair 0, 5. And then finally, in the last line of my table, y is 0. So this time I'm looking for x. So I'm going to replace the y with a 0. So I start out with x plus 2y equals 10. If I plug a 0 in for the y, I get x plus 2 times 0 equals 10. And 2 times 0 is just 0, so I end up with x plus 0, or just x, equals 10. So the x was a 10 and the y was a 0, so that gives me the ordered pair 10, 0. Well, as I mentioned, the above table is called a table of values. A table is just a good way to organize your ordered pairs. These tables can be drawn vertically, as in the example above, or horizontally, as in the next example. So let's look at another example. I want to use the equation 2x minus 3y equals 12 and complete the following table. So this time my first row represents my x values and my second row represents my y values. And again, in this class, you're always going to give the final answers as ordered pairs. So for the first ordered pair, x is a 0. And I'm using the equation 2x minus 3y equals 12. So replace the x with a 0, and I have 2 times 0 minus 3y equals 12. Well, 2 times 0 is 0, so I just have negative 3y equals 12. Now if I divide each side by -3, I get y is -4. We can put that -4 in our table of values, but also remember to write this as the ordered pair. X is 0 and y is -4, so we have the ordered pair 0, -4. Next, my y is 0. So begin with the equation 2x minus 3y equals 12, and this time I'm going to replace y with 0 and solve for x. So -3 times 0 is 0, so I end up with 2x equals 12. Divide each side by 2, and I end up with x equals 6. So in my table, the x value is a 6, and this gives me the ordered pair 6, 0. And then finally, x equals 3. So start with the equation 2x minus 3y equals 12, and I'm going to replace the x with a 3. So I have 2 times 3 minus 3y equals 12. This gives me 6 minus 3y equals 12. I solve for y by first subtracting 6 from each side, and I get -3y equals 6. And then finally divide each side by -3, and I get y equals -2. So I can put -2 in my table, and then this gives me the ordered pair 3, -2. Next, we want to look at graphing linear equations. And in this class, we're going to look at 2 ways to graph the linear equations. The first way, we're going to use a table of values. This is generally the easiest way to graph an equation if the equation is in slope-intercept form. If the y is isolated by itself, the easiest way is to create a table of values. You pick several values for the x because it has the other numbers around it, and the y is the one that's isolated. Plug those values in for x and solve for y. And the best way to organize these is using a table of values. So we'll look at a few examples of this. I want to graph the following equations. First, y equals 2x plus 3. You can set up these tables any way you want to. Some tables are like the ones we just did that just have an x column and a y column. And they can be vertical like this one or horizontal. I set up this table so that I can show my work in it and then write my ordered pairs. But you can set up the tables any way you want to. If you don't know which values to start with, the best values to begin with are -2, -1, 0, 1, and 2. This gives you a couple of negative numbers, it gives you 0, and a couple of positive numbers. But you can pick any x values that you want. So if I start off with x is -2, I have y equals 2 times -2 plus 3. This gives me -4 plus 3, so that tells me y is -1. So this is the ordered pair, -2, -1. Next, let y equal -1. So I have y equals 2 times -1 plus 3. This gives me y equals -2 plus 3, which is a positive 1. So I have the ordered pair -1, 1. Now let y be 0. This gives me 2 times 0 plus 3, which is just 0 plus 3. So y equals 3. So this gives me the ordered pair 0, 3. Then let y equal 1. I have 2 times 1 plus 3, which is 2 plus 3, so y equals 5. And this is the ordered pair 1, 5. And then finally, y equals 2 times 2 plus 3. So y equals 4 plus 3, which is a 7. So I have the ordered pair 2, 7. I've set up my table of values so that I have 5 points. You only need 2 points to graph the line. It's safe to have 3 or 4 points or even 5 points, because if you only have 2 points and you make a careless mistake and miss one of those, you're going to graph the line wrong. But if you have several points and all those points line up, that's a way to check yourself. Now when you're graphing this, for the 2, 7, if that 7 is too large to graph, you don't have to graph it. You could just graph the other 4. So let's look at plotting these points. When I drew my x and my y-axis, I put my y-axis sort of in the middle because my x values, I only had to go to -2 and +2. But if you notice, for my y values, I have to count all the way up to 7, so I drew my x-axis a little bit lower. That's another tip to help you graph the values if they are a little larger. So plot the point -2, -1, -1, 0, 0, 3, 1, 5, and 2, 7. And after you plot the points, you notice that they do form a straight line. So that's a way I can check my work on these ordered pairs. Once you get your line plotted, draw a straight line through them. This line represents all the solutions for this equation. These 5 ordered pairs were just 5 points on that line. This line had a lot of other solutions. It looks like this point right here may be -1.5 and 0. And that's a solution on the equation. Whatever this fraction would be right here would be another solution on the equation. So every single point on that line represents a solution to the equation. Let's look at another example. Suppose I have y equals -x plus 2. When your equation contains a negative and you're plugging in a negative number, be sure not to drop the negatives. When I plug in a -2, I'm going to have a negative from the equation, and then I have a -2, the value that I'm plugging in. This double negative gives me a +2 plus 2, so I get a y value of 4. So this gives me the ordered pair -2, 4. Next, when I plug in a -1, I have a negative from the equation and then a -1 from the value that I'm plugging in. This double negative gives me a +1. And then when I add my 2, I get a y value of 3. So this is the ordered pair -1, 3. Next, I plug in a 0, so I have a -0 plus 2. Well, a -0 is just 0, and 0 plus 2 is 2. So this gives me the ordered pair 0, 2. Then I plug in a 1. I have a negative from my equation, and then I plug in a 1 plus 2. So this is just -1 plus 2 is 1. So I have the ordered pair 1, 1. And then finally plug in a 2. I have a negative from my equation, and then the 2 that I'm plugging in, and then the plus 2 from the equation. So this gives me -2 plus 2, which is 0. So my final ordered pair is 2, 0. So now I want to plot these ordered pairs. I don't have any x or y values that are extremely large, so you would be fine putting your x and y axis fairly in the center. Since I had to count up to a 4 for my y's, I dropped my x-axis down just a line or 2. So when you plot these ordered pairs, you do see that they line up in a straight line. So that's a way to check my work when I completed my table. And then connect your ordered pairs with a straight line. Now the next way we're going to look at for graphing an equation is using the intercepts. So let's just first consider the graph that I have below. And I want to ask myself, what point does the graph cross the x-axis? Well, the graph is crossing the x-axis at the point 5, 0. Next, we want to look at what point does the graph cross the y-axis. Well, our graph crosses the y-axis as the point 0, -3. Any point where the graph crosses the x-axis is referred to as an x-intercept. And likewise, the point where the graph crosses the y-axis is called the y-intercept. Well, if you look at any point that's going to cross the x-axis, that would be any point on this horizontal line. Well, this is the point 1, 0, 2, 0, 3, 0, 4, 0, 5, 0 was the intercept that we had. But if you notice the pattern, for every point on the x-axis, the y value was always 0. Now consider the y-axis. This is the point 0, 1, 0, 2. This is the point 0, -1, 0, -2, 0, -3. For the y-axis, every x value is 0. I'm going to use this fact to find the intercepts of the graph. So in any x-intercept, the y-coordinate is always 0. So I can find the x-intercepts by replacing the y with a 0 and solving for x. And likewise, in any y-intercept, the x-coordinate is always 0. So I can find the y-intercept by letting x be 0 and solving for y. So let's look at some examples. I want to graph these equations using the intercepts. In a future lesson in the next module, this is going to be the main way that we graph equations. Even though this equation is y equals, and I mentioned that a table of values would be the easiest way to graph it, in a future lesson we're going to need the intercepts to solve the problems. So let's just practice this one, graphing using the intercepts. So if I'm looking for the x-intercept, in any x-intercept, my y value is a 0. So it's going to be an ordered pair. You will always write your intercepts as ordered pairs. And you can go ahead and let y be 0. So then go to your equation, y equals 3x minus 9, and replace the y with a 0. Now I want to solve for x, so I add 9 to each side, and I get 9 equals 3x. And then divide by 3, so I get that x equals 3. I plug this into my ordered pair, and I get that my x-intercept is 3, 0. Now I want my y-intercept. For any y-intercept, your x value is always 0. So go to your equation, y equals 3x minus 9, and this time replace the x with a 0. Well, 3 times 0 is 0, so I just get y equals -9. So my y-intercept is the ordered pair 0, -9. Now I want to graph these. For the x-intercept, I've got to count over to 3, so I can put my y-axis sort of in the center of my graph. For the y-intercept, I have to count down to -9. So I want to make my x-axis high enough so that you've got 9 spaces below it. So plot the ordered pairs 3, 0, and 0, -9, and then draw your line through them. Well, our next example is in standard form. I have 3x minus 6y equals 12. So to find the x-intercept, you let y equal 0. So start with the equation 3x minus 6y equals 12 and replace the y with a 0. So I have 3x minus 6 times 0 equals 12. Well, 6 times 0 is just 0, so I end up with 3x equals 12. Now if I divide by 3, I get that x is 4. So my x-intercept is the ordered pair 4, 0. Always write your intercepts as ordered pairs. Now for the y-intercept, let x be 0. So I have the equation 3x minus 6y equals 12, and this time put a 0 in place of the x. So I have 3 times 0 minus 6y equals 12. This just gives me negative 6y equals 12. And if I divide by negative 6, I get that y equals negative 2. So my y-intercept is the point 0, negative 2. Now I want to graph these. Neither my x or my y values are large numbers, so you can put your x and y axis in the center of the graph. Plot the points 4, 0 and 0, negative 2, and then draw your line through them. Now let's look at the next example. I have 3x plus y equals 0. So begin with the x-intercept by letting y be 0. So begin with the equation 3x plus y equals 0, and we're going to replace the y with a 0. So we get 3x plus 0 equals 0. This just gives me 3x equals 0. When I divide each side by 3, I get that x is 0. So my x-intercept is the point 0, 0. That point 0, 0 is also the origin of the graph. That's that very center point where the x and y axis cross each other. Now for my y-intercept, I let x be 0. So I have the equation 3x plus y equals 0. And this time I plug my 0 in for x. So I have 3 times 0 plus y equals 0. Well, this just gives me y equals 0. So my x and my y-intercept are the same point, that origin, the 0, 0. Since my x and my y were the same point, I need a second point to graph the line, because that 0, 0 is only one point. So to find a second point, you let x or y be any number and solve for the other variable. So for my second point, I'm just going to let x be a 1. So I have 3x plus y equals 0. I let x be 1, so that gives me 3 plus y equals 0. If I subtract 3 from each side, I get y equals negative 3. So this gives me the ordered pair 1, negative 3. And you could have let x or y be any value you wanted. I just picked the 1. So we're going to plot the point 0, 0 and 1, negative 3. When you get those ordered pairs plotted, then draw your line through them. Now we're going to look at some special lines. We're going to look at vertical and horizontal lines. So suppose we had the equation y equals negative 2. This time I just have a y value. I don't have an x value. So I want to know, what does this graph look like? Basically, what happens when my equation does not contain an x? So if I do a table of values, I can let x be any value I want. So this time I just did 3 points, the negative 1, the 0, and the 1. Well, normally I would plug these values in for x, but I don't have an x value. So no matter what that x is, my y is always going to equal a negative 2. So this gives me 3 points, negative 1, negative 2, 0, negative 2, and 1, negative 2. If I plot those 3 points on my graph, you see that they're all in a horizontal line. so I can connect those with a horizontal line. So basically, whenever you have the equation of the form y equals a, when there's no x value, only a y, and a can be any real number, the graph is going to be a horizontal line passing through that number a on the y-axis. So anytime the x is missing and you only have a y, it's a horizontal line. Well, now what about if you just have x equals to a number? So I have the equation x equals 3, and I want to know, what does this graph look like? This time, if I do a table of values, I can't let x be any number. X has to be 3 every single time. Since I don't have a y value, my y can be any number. So I'm going to let y be -1, 0, and 1. So this gives me 3 ordered pairs. I have 3 -1, 3 0, and 3 1. When I plot those ordered pairs, I see that my points are lining up in a vertical line. So whenever I have the equation of the form x equals a, where a is any real number, the graph is going to be a vertical line passing through that point A on the x-axis. So when your equation does not have a y, when it only contains an x, that's a vertical line. So once you learn that when you have y equals to a number, it's a horizontal line, and x equals to a number, it's a vertical line, these are real quick to graph. So if I have y equals -2, since it's y equals, it's a horizontal line. So find this value -2 on the y-axis and draw a horizontal line through it. If I have x equals -4, when x equals a number, that's a vertical line. So find -4 on your x-axis and draw a vertical line through it. And on a quiz or a test, if you get these two mixed up, just create a table of values and plot the points, and that'll help you remember which one. In the next example, I'd still just have a y. I don't have an x value, but I have y plus 5 equals 9. I want to get that y by itself. So subtract 5 from each side, and I get y equals 4. Well, y equals a number is a horizontal line. So find 4 on your y-axis and draw a horizontal line through it. Next, I have 4x equals 8. So again, I just have an x value, so I know it's going to be a vertical line, but I want to get that x by itself. So since it's 4 times x, divide each side by 4 and you get x equals 2. So find 2 on your x-axis and draw a vertical line through it. Now for y equals 0, it's y equals a number, so I know it's going to be a horizontal line. So find 0 on your y-axis, and that's right here at the origin. Well, if I draw a horizontal line right here, that's actually my x-axis. So I'm just drawing my horizontal line over my x-axis. So the equation of the x-axis is going to be y equals 0. If I have x equals 0, since there's no y, I know it's a vertical line. Whenever you have x equal to a number, it's a vertical line. So find 0 on your x-axis is right here at the origin. And if I draw a vertical line through it, I'm drawing my line over my y-axis. So the equation of the y-axis is x equals 0. Next, I want to give the equation for the following lines. When you're asked to give the equation of the line, the first thing you've got to decide is what variable to use. Since it's a vertical line, I'm going to use the variable x. So my equation is going to be x equals some number. The next thing you decide is which number you use. Well, since this vertical line is crossing my x-axis at 4, I'm going to use 4. So the equation of my line is x equals 4. In the next example, I have a horizontal line. Since I have a horizontal line, I know my variable used is a y. So to determine the variable in your equation, you decide if the line is vertical or horizontal. Next, I determine my number. Since this line is passing through 2 on the y-axis, the number in my equation is going to be a 2. So I have the equation y equals 2. So when you're given the equation of the lines, the first thing you determine is the variable. You decide the variable based on what type of line you have. If it's a vertical line like my first example, you have x equals. If it's a horizontal line like the second equation, you have y equals. So if you're ever asked how do you know which variable to use, it's based on the type of graph. Vertical lines are x equals and horizontal lines are y equals. Next, you determine the number. The number is based on where that line crosses the axis. Since the first example crossed the x-axis at 4, I use the number 4. Since the second example crossed the y-axis at 2, I use the number 2. So in the next example, the first thing I've got to determine is the variable used. Since it's a vertical line, I'm using the x. Then I decide which number. Since this line passes through -5, I'm going to use -5. So my equation is x equals -5. And then finally, I have a horizontal line passing through the y-axis at -6. Since it's a horizontal line, I'm going to use y equals. And since it crosses the y-axis at -6, my equation is y equals -6.